Hello, everyone. Today we're going to solve together the Leet code question, merging two sorted lists. Now, for this question, it specifically defines us using a node list, or essentially creating a linked list as our final result. So we get two linked lists, and then we go ahead and merge them to a final merged list. However, I felt that for the sake of this problem, it'd be best if we go through the logic using two vectors instead. And then afterwards, in a separate video, we'll go ahead and use the actual linked list approach, just because I want you to feel comfortable with the logic before we continue on to incorporating new concepts such as linked list. That being said, let's go ahead and take a look at what it's asking us. So we're given two lists. And once again, we're replacing these with vectors, and we want to merge them into one sorted list. And so we're going to splice together the two parts of the two individual lists to get the merged list. Now, please note that the linked list is actually in ascending order. So they're both ordered lists, the two lists that you'll be provided. And then we want to go ahead and have our final merged list in order as well. So for example, notice, so I have the first list being 1, 2, 4, and then the bottom list being 1, 3, 4. So my result set is going to be all these 6 nodes, or all these 6 values or elements, I should say, and it's going to be in order. So the 1, 1, 2, 3, 4, 4, and that's exactly what we have at the bottom right here. Now you can see that if there's no values within, or there's no elements within our two lists, then our output should be nothing, right? So if we don't have anything to merge, then we're done as it is. If, let's say, for example, we have one list that's empty and one list that's full, well, then the result set is really just going to be the list that has values, right? And we'll extend this idea in just a moment, but this idea is really important, so that when you run out of values or elements for one list, all you do is you essentially just start adding the values from the other list that's not yet over. So while values still remain on one list, then those are the values you're just going to carry over. That's really the concept behind these. We're going to go ahead and now take a look at it through here. So let's go ahead and use vectors instead of using, once again, a nodes and kind of singly linked list. So here's our two example lists. So you can see we have the values 1, 2, 3, 4, and the values 1, 2, 5, 6, 7, 8. They're both in ascending order. And what we want to kind of realize is that if we're creating a result set that comes from both of these, it's that if this has 4 values in it and this has 6 values in it, our final result set will have 10 values. And for this given example, and that's really because what it's going to be, our size is going to be the size of our first list plus the size of our second list. That's just something to consider. So that's how many iterations we're essentially going to perform. And then what's the logic behind these two? So what we're going to do is we're going to have 2 pointers. We're going to have a pointer that starts at our first list and a pointer that starts at our second list. Once again, these are not actual pointers with respect to C++. These are just kind of indices that we're referring to. So we'll start them at the beginning of the list. And what we're going to do is we're going to decide, is the first list value, the first element value, less than or equal to the second list value? Now notice I say equal to, and that's because whenever we have an equal situation, whenever we have kind of a situation where they're the same value, then at that point we have to choose arbitrarily. Do we want to use the first list or the second list? It doesn't really matter which one you choose, but I'm just choosing to use the first list. It's kind of simpler. So notice if the first list is smaller or equal to the second element that it's pointing to, then we're going to go ahead and use that. So here's our result set. And so notice I'm going to go ahead and place the 1 from the first list on here like that. And then I'm going to move it forward. Now we're going to go ahead and do a comparison between the two values. Is the first value or first element less than or equal to the second element? And that's not the case, right? The second element is actually the lesser value. So we're going to put a 1 there. And we're going to push this list or this pointer forward. Now we compare the two again. Who's smaller? So the first is smaller or equal to. So we're going to use the first list. So put that right there. And then I'm going to shift it over. I'm going to go ahead and do standoff between the 3 and the 2. The 2 is the smaller value, so we're going to go ahead and take the 2 and push it forward. 2. Let's continue. So let's go ahead and grab between the 3 and the 5. Which one's the smaller value? The 3 is the smaller value. So I'm going to grab that from the first list, move it forward. Then afterwards, we're at 4 and 5. Who's the smaller value? The smaller value is going to be the 4. So we're going to put the 4 there. And notice the first pointer is going to go out of bounds. So once it's out of bounds, there's no real values that I can get from here. So the only values that are left are going to be these values within the second list. So essentially what we're going to do is we're going to say if one of them is out of bounds, then what you're going to do is to the remainder value, you're going to go ahead and start adding those to my list. So since this one's out of bounds, just ignore it and just stick with this value, or stick with this list, I should say. So we're going to go ahead and add the element 5, push our pointer forward, add the element 6, push our pointer forward, add our element 7, push our pointer forward, add our element 8, push our pointer forward. And notice now that we've reached the end, of both lists, we're good. We're complete. And another way we could perform that check is once we've reached, in this case, 10 iterations, which we've had to have performed, then we're complete because that's our result set. And just like that, you can see it's in order. So the main logic is going to be comprised of something like this. So if both lists are within bounds, so if I still have both lists that exist, what we're going to do is we're going to consider this case. If the first element is less than or equal to, I don't know why I'm writing that. So less than or equal to the second element, use the first element, add that to our result set. If that's not the case, then we want to use the second element. So that's the case when both are within bounds. But if both are not within bounds, then we have to consider. So if both are not within bounds, we know that only one list is left. It's either going to be list 1 or list 2. So if list 1 is within bounds, add the element from list 1. There we go. And then if that's not the case, then list 2 is within bounds. Add the element from list 2. And that's really the logic behind what we're going to be doing. So I hope that made sense. I try to use kind of a test case to show kind of the logic between the two. The list logic also covers the instances where we have 2 empty sets, because if we have 2 empty sets, then our pointers, so essentially the number of iterations we're going to perform is going to be the addition of the 2 sizes. But if we have size 0 plus size 0, we're going to perform 0 iterations, right? So that's pretty much it. Let's go ahead and start with the implementation. I'm going to go ahead and I guess I could leave this here. Yeah, those notes just for reference. So let's go ahead and start off. So what I want is my function to return the merged list. We're going to call it merged list, and we're going to take in 2 lists. And so for good measure, we're going to pass these by reference. So we're going to have list 1 and list 2. There we go. Now, we know that the new list size, as we mentioned before, is really just going to be list 1 size plus the size of list 2. Okay, and that's going to be the number of iterations that we're going to perform. Well, we also want our 2 pointers. We want our F and our S, right? We want them to start off right at the beginning. So essentially, they would be right here. So they would be at index 0. So here we have int list 1 index is equal to 0. And this is going to be our list 1 quote unquote pointer. And here we have list 2 index, which also starts at 0. And this is our list 2 pointer. Okay. Next up, I kind of like to keep it clean whenever I have indices that I'm using. I actually also like to have separate variables that refer to the actual elements. This way, we don't have to kind of reference the vector name and then use the index. This way, we can always have a way to reference directly the element. So we want to refer to the current elements we are on for each respective list. And so for that, we're going to create the elements list1 value and or list2 value. And right now, these are just placeholders. We haven't initialized them. Once we're inside of the loop, we'll go ahead and initialize them accordingly. And then the last thing that we need to set up is we need to set up a temporary space for our result set. So we want to go ahead and create our new list. So this is going to be the new list that we return at the end of this function. So how many times do we want to iterate in order to achieve our goal of merging the list? Well, we want to iterate the same number of times that are on the size of both lists. So essentially, in this case, since there's 4 elements and here there's 6 elements, so we know we want to perform 10 iterations because we have to individually add each of the elements, right? So that's how many iterations we should be performing. So we're going to use our standard for loop to start at 0, I is less than the new list size, which is just a combination or an addition of the 2 sizes. And then we're going to go ahead and iterate. So iterate the same times as the size of the new list, right? Which is that. The next thing that we want to consider is we want to consider the instances where we have both of our lists within bounds, both of our lists within bounds. So that's the case where we saw initially. In this case, there's both of our lists are within bounds, so our pointers are still within bounds. So here I have 1 and 1, and they don't have to be the same value. It's just that both of them are being compared. So how do we set that up? We just say if the list 1 index is less than the list 1 dot size. So if it's within bounds and the list 2 index is less than the list 2 dot size, then both lists are within bounds. All right, so I'm inside of both lists. Now that we know that both are valid, we can go ahead and set up our elements. So the first and the second. So this is index 0, this is index 0, but I also want to know what values are there. So this is going to be element 1 and the element with the value 1. So we want to set up our elements for both lists. Okay, and so once again, we've already had these variables declared. Let's just go ahead and assign them. So list1 value is equal to list1 at the index list1 index. Right. And I just feel like this is going to be more readable in this way. So here's my list2 value, which is list2 at the index list2 index. Okay. Now that we know we're within the scope of both lists and we have those numbers, which number do we want to add? Well, we want to add the first number if it's less than or equal to the second number. And we only want to add the second number if it's not less than or equal to the first number. So let's go ahead and set up that if logic. So if the list1 value is less than or equal to the list2 value, right? So in other words, if our first list has the smaller or equal value, we want to go ahead and add it. So the way we do that is we go to our new list pushback. We want to add the list1 value, but we also want to make sure that what did we do every time we added a value? So if I added the 1, I also had to push the pointer forward. So in this case, we're going to push the pointer forward as well. So we're going to say list1 index is going to be pushed forward. Now, what if this wasn't the case? Then we know we're going to use the second list value. So if that's not the case, so in this case, it would be our second list as the smaller value. Then we want to add the second value to our list. We're going to say new list dot pushback the second list value. Okay, and then we're going to push the second list index forward, because every time we use it up, we want to go ahead and move it forward. Now, if this is within bounds, we're going to perform this logic. Once it's done, that's it. That's all we did. So we know that we've added to our new list, either in this instance or in this instance. So I don't want to continue this iteration or I don't want to continue with this iteration any further. So I'm going to use the continue keyword. This handles the instance once again when both of our lists are within bounds. But what happens when only one list is within bounds? So we can only get to this section of the code due to our continue statement. We can only get to this code if both of our lists are not within bounds. Because if it is, then we know we're going to hit this statement. So if both our lists are not within bounds, so only meaning only one list is left, then we're going to have these two scenarios. Either the first list is left over or the second list is left over. That's pretty much it. So let's consider when the first list is left over. So if the list one index is less than the list one dot size, meaning that the first list is still within bounds. What do we want to do at that point? If only the first list is left, we want to add its value to the new list. Right, that's pretty much it, because that's our only option at that point. So what we want to do is we want to set up our value. So list one value at this point should be list one. I think it was list one at the list one index. There we go. And we want to go ahead and add that value, new list dot pushback that value into our. We want to add that value to our result set. And then don't forget, every time we add a value, we want to go ahead and push it forward, just like we did in this situation when the only thing was left with was this 5 because we ran out of all these numbers. Remember, we added the value, pushed it forward, added the value, pushed it forward, added the value, pushed it forward, and so forth. So we're going to go ahead and push the index forward like that. Now, what if it's not the case that the first list is within bounds? We want to go ahead and check if the second list is within bounds. So if it's within bounds, the second list is still within bounds. Add its value to the new list. So it's just going to be a repeat of this logic. So we're going to go ahead and set up our second value. It's going to be list 2 at the list 2 index. There we go. We're going to go ahead and push it onto our result set. And we're going to go ahead and push the pointer for that one forward. And that's it. So that's the logic to get the result set. Once it completes this logic from the for loop, you're going to have your new list set up with the merged ordered list that comes from the two inputs. And so the last thing we always need to do is we just go ahead and need to return a copy of our list. So if we wanted to see this in action, all we would go ahead and do is let's create results. Let's say like a results. Yeah. And the way we get our result is we go ahead and call merge list, and we pass in 2 arguments, which is the first list and the second list. And then we're going to go ahead and print them out. Let's say that the results set is, or the merged list, we could also say that, is, let's use a for each loop to go ahead and go through our elements. And this is called results. And let's just print all of them. Let's just print all of them here. So we're going to print out each element with the space between them. So once we run that, we can see that here we get the result set. So this is going to be 1, and then this 1, 2, this 2, 3, and then 4, 5, 6, 7, 8. So once we get to the 5, it ran out of the first list. So we're just going to get the remaining values. This also works for the test cases, just to kind of show if I were to have 2 empty lists. Notice it's not going to print out anything. Or let's see. Oh, no, that was a syntax error. I made a mistake right there. That was a bit of a syntax error. Let's say if I only had values in the first list, 3. So you can notice that it prints out correctly. Just the values from the first list. If there's only values in the second list, it'll only print out the values in the second list. One thing to be careful of is if you are going to be using these variables, which get assigned the element values, it's make sure to set them up within the correct scope. Just because initially I set these up I set both of these up right here. And the problem with that is, well, I can only assign both values if both are within bounds. So that's this specific block. So if I'm within bounds of both lists, then I can perform this action. So I actually got an issue before, because what if only one list is active? If only one list is active, then I went ahead and had an out of bounds array error. And so just be careful of that. That's just something to be mindful of. Thank you so much for watching. Please like, share, and subscribe if you enjoyed the content. Let me know if you had any questions and if this made sense. I also hope you appreciate that kind of we took a vector approach instead of the linked list, singly linked list approach, just because this one kind of adds a smaller, a little bit more of a layer of complexity. So I just wanted to make sure you understood the logic before we kind of attack that next problem. I should be tackling that sometime within the next week or so. So thank you so much for watching, and I hope to see you soon.